In this video, we're going to do this homework assignment, which is taken from page 477 in the Blitzer textbook. And the assignment was to do the even numbers. I like the way this book is set up because the homework assignment is the even numbers, which we're going to do together. The odd numbers are very similar. If you look at them, it's really the same problem, just with different constants. And here you can get the answer in the textbook. So if we do the evens, you can then go back and do the odds and check the answers in the textbook. Okay, let's start with, I'm going to do 41 and 42 just to get warmed up. So on 41, what do we see? We see log to the base 10 of 5, log to the base 10 of 2. Very important to notice that these bases are the same. When these bases are the same and the coefficients of each of them are 1, you can combine these into one log. They call it condensing. When you do, the arguments can be multiplied together. Notice we went from writing the word log twice to just once. That's very important. Our base is 10, so this now becomes log to the base 10 of 10. Now, from a previous video, you might remember that whenever the base of a log matches the argument exactly, this neutralizes and becomes 1. Just like you're canceling out 5 over 5 in a fraction, they neutralize and become 1. Same thing here. However, if for whatever reason you don't remember that, no problem. All you do is the whirlybird technique. So now we're trying to evaluate this. Okay, so we have log to the base 10 of 10 equals x. We raise the base to x, and that will equal the argument. There's a hidden 1 there, as usual, very helpful, and we pattern match. Excuse me, if the bases are the same, and there's an equal sign here, the only thing that's left are the exponents. So by definition, they have to match. Next problem, very similar. Again, the coefficient out here is 1. Here it's 1. We are allowed to condense these. Don't forget to check to make sure the bases are the same. Now, ladies and gentlemen, if there happens to be a coefficient in front of the log, you just bring it up here as an exponent and proceed in a similar fashion. So here, I'm only going to write the word log once. It's still going to be base 10, and we're going to have 4 times 250. That argument now becomes 1,000. We set that equal to x, and then we have 10 to the x equals 1,000, which equals 1,000 equals 10 to the third. Therefore, x equals 3. Okay, now we're going to stick with the evens. Now, on these problems here, they just want you to condense them. There's no way to solve for x here, because if you did, you would have this is an expression. There's no equal sign here, and we cannot solve this, because then we'll have 2 unknowns in one equation. So ln is the natural log. Don't forget it has the base e, which is Euler's number, which is about 2.71. It's a constant, just like pi equals 3.14. These are both irrational numbers. They go on forever. E is 2.71. It has to do with continually compounding interest, which we'll cover in the next week or so. ln 3 can be evaluated with a calculator, but that's not what they're after here. They want you to condense these. So let's do that. Let's make, instead of writing the ln word once, we're going to write it, twice, we're going to write it once. The base stays the same, and now we can multiply these. So that would be the condensed version of this. Again, we're only writing ln once instead of twice. Okay, let's go to 46. Okay, here we can evaluate this. Unlike here, where it was an unknown, we now have a constant for the argument, so we can evaluate that. That's the difference between those two problems. Okay, so let's look at this. Now we have a minus sign, okay, different than the plus sign, obviously, and here we're going to create a fraction. So the property of log says if we have the same base and there's no coefficient out in front, we can combine these into a fraction. As we'll see in future examples, whenever there's a plus sign, the argument goes in the numerator. Whenever there's a minus sign, the argument goes in the denominator. So this becomes log, again, I'm only writing the word log once. 405 is in the numerator and 5 is in the denominator. Okay, if you simplify that argument, you're going to get log of 81 base 3. Now we'll set that into x, 2x, excuse me, and now we have 3 to the x equals 81. And we know that 81 can be broken down to 3 to the 4th and x equals 4. Really quickly, how do we know that 81 is 3 to the 4th? 81 is 9 times 9. That's 3 squared times 3 squared. When the bases are the same and we're multiplying, we are allowed to add the exponents, and that's how you get 3 to the 4th. Let's go to 48. Here we have a minus sign. We know that this argument is going in the denominator, and this has a plus sign out front. That's going in the numerator. We're going to write the word log once, and we're going to have 3x plus 7 is in the numerator, and x is in the denominator, and again, we cannot go any further because x is an unknown. Notice the word log is written once. That problem that you see is different than this. These are not the same. Notice, in the problem, log is written twice. Here it's written twice. This is not the same as problem number 48. Look, it can't be the same. Well, what we did is we took these terms being subtracted from each other, we switched it to dividing. We can't do that. That's like taking the numbers 4 minus 3 and saying that equals 4 over 3. Okay, completely untrue. So remember, don't have the word log written twice if you're trying to condense and switch it. You go from log written twice to log written once. This is the correct version, in case I've confused you with all this. Okay, what's going on here? Okay, here, this 7 is out front. So before we can combine these, we have to move that 7 up as an exponent. Once we do that, we have the same base of both logs, and we can then combine them. So it becomes log of x plus log of y to the 7th power. So all we did is we took that 7 and we brought it up here as an exponent. Okay, now they're both plus signs, so they both go in the numerator. We write the word log once, and we have x times y to the 7th. That is your final answer. Okay, number 52. Okay, same situation. Both plus signs. That means the arguments are going to go in the numerator when we combine them. ln is written twice. We're going to make it once. We cannot proceed yet, however, because we have 1/3 out here in front. So we have to bring that to the top. And then the y can be written as is, and the final answer is as shown. I don't know if your teacher might want you to change that to ln cubed root of x times y, but both of these are correct. Okay, let's do 54. Okay, you see what's going on here, ladies and gentlemen? We have coefficients in front. We're going to have to bring those up as exponents. They're both positive, so they're both going to be in the numerator. And our final answer here is going to be log base b x to the 5th times y to the 6th. Done. .56. Okay, similar problem. See that minus sign? That means that y goes into the denominator. That means we have to create a fraction. As soon as you see a minus sign involved, we have to create a fraction. Up top, because this is a positive out front here, that's going to become x to the 7th power after we move the exponent up. And on the bottom, we're going to have y cubed once we bring the cube, this 3, to the y's exponent. Notice, ln is only written once, not twice. 58. Similar thing. We're going to bring these exponents up. We're going to put this argument in the denominator because of the negative sign. Okay, so we're going to write ln once. We know there's a fraction because there's a minus sign involved. On the bottom is going to be y to the 1/2, and on the top is going to be x squared. Okay, what's going on here now? Okay, so here we have, very simply, a little bit extra in this term. That's okay, in this argument I should say. We're going to bring this 8 up, we're going to bring this 4 up, and we're going to have the same situation. So we're going to write down ln once. We know there's a fraction because a minus sign is involved. X to the 4th on the bottom, x plus 9 to the 8th power up top. Okay, see a minus sign there? That means we're going to have a fraction. We're only going to write ln once. We're going to combine all these. Remember, this coefficient can't be out in front. We're going to bring that up, make that x to the 4th. We're going to bring this up, make that y to the 7th. We're going to bring that up, make that z to the 3rd. Anything with a negative sign is going to go in the denominator. Anything with a positive sign is going to go in the numerator. Okay, so we're going to have x to the 4th in the numerator, y to the 7th in the numerator, and z to the 3rd in the denominator. And it is just that simple. 64. Okay, what's going on here? Okay, when I see this, ladies and gentlemen, I think it's just easier to do what we know how to do, and that's just distribute. Okay, if you're not sure what to do on some of these problems, do what you know to be legal, and then go from there and see if something pops out at you that allows you to figure out the problem. Don't guess. If you're not sure whether you can bring this 1/3 up here or not, just do what you know, okay? And it turns out you can't do that. Okay, 1/3 log to the 4th of y. Okay. Now, what do we know how to do from here? We know how to bring this up. So now you have log to the 4th x to the 1/3 minus log to the 4th y to the 1/3. You have a minus sign. That means when you combine these into one log, there will indeed be a fraction. The base stays the same. Y to the 1/3 goes on the bottom because of that minus sign. There's a plus sign out here, x to the 1/3. Okay. You now recognize this, ladies and gentlemen, as something that could be placed into one exponent because of the power rule. And don't forget to double check if you distribute this power, you get that. That's it. Next one, we are now up to 66, I believe. Okay, we'll do this one a little bit differently. This time, we're going to go ahead and combine this first, and then apply the 1/3. So we take what's in those parentheses. You see 2 logs here. We're going to combine those to 1 log. You see a minus sign, that means by definition you will have a fraction. We're going to keep the base the same. We're going to keep that 1/3 out front. And we're going to combine these to y in the denominator because there's a minus sign, and x in the numerator. We're going to do the same thing with the next term. Actually, yes, we're going to do, let's move to the next term. So here we can just bring this exponent up here. That is legal. Let's do that. Okay, why did we do that? Because eventually we're going to try to condense this, and we can't do that with that 2 out front. So we had to do that. So now this coefficient is 1. We're going to take this and we are going to bring that to that. So this becomes log base 4 of x over y to the 1/3. We are now going to bring this up front, up top I should say, and that's going to equal log to the base 4 x over y in parentheses to the 1/3 plus log base 4 x plus 1 squared. Because both of these have 1 in front of them and it's the common base, we can combine these. Now, we will end up having log base 4 of xy to the 1/3 times x plus 1 squared. And that is your final answer. All we did was condense these into 1. And if you want, you can make this a little neater and make that log base 4 x over y to the 3rd root times x plus 1 squared. Okay, sorry that it was a little crowded there. Okay, 68. Okay, what's going on here? What I'm going to do is I'm going to leave that 1/3 alone for a second, and I'm going to combine all of these. Now, before we do that, we have to take this 5 and bring it up. We notice we have some minus signs. That means all this is going to go in the denominator, or these 2, I should say, are going to go in the denominator. That's going to go into the numerator. All right, so we're going to keep the 1/3. Okay, so we're going to keep the 1/3. We are going to write ln once, we're going to put x plus 6 to the 5th in the numerator. Okay, again, we got that by just taking this 5 and bringing it up as an exponent. We're going to create our fraction, and the other arguments go in the denominator. And you could rest there, or you can bring the 1/3 all the way up here, and the final answer could be and then if you want to go further, you can apply the power rule here and make that 5/3 and then make that 1/3 and that 1/3. But I'm not sure you have to go that far. 70. Okay, 70, I have a note to look over. Let's see. Okay, this is problem 70. Problem 70 is as follows. Log of x plus log of x squared minus 4 minus log of 15 minus log of x plus 2. Okay, so what's going on here? We're going to write the word log once. I'm sorry, this first one is not log to the base x. It's just log of x. They all have a base of 10. They're all the same. They all have 1 as a coefficient, some negative, some positive. Because we see in negatives, we know by definition we're going to have to put something in the denominator. And that is 15 times x plus 2. Now, this is the difference between two perfect squares. I didn't do this on the last problem, but we could have. And this becomes and then these cancel out. So your final is going to be and that's the end of this video. Thank you.